Welcome back to the channel. Today is our second lecture of our DSA course where we will be covering about maps and sets. We are going to cover all the important techniques and all the possible places where you might use a set or a map for solving your desired problem. Maps and sets are both very powerful data structures. They can be used for efficient insertion, efficient removal, and efficient searching of data. For more detailed explanation on how a map or set works, make sure to check out our introduction to data structures video. I will pin the link in the description. Now let's move on to very important applications of map and set. Now, the disadvantage of set was that it can store only single values and you cannot store duplicates. So, the problem arises when you need to search among a space where there are multiple elements of the same value. Whereas in maps, the elements are stored in a key value pair and you can use this value to your advantage in many ways. So now I'll show you all the different ways how you can use this value. So the first application of maps comes when you store your value as a frequency or a count. This comes in handy when suppose you have some data and you need to search and then remove. Now if an element is present twice and after searching once you remove it. So when you want to search it again, you should get a true value because there is still one occurrence of it left in your data. But when you use a set and you remove the value directly, then it doesn't keep count of your frequency. But when you use a map, the value can be used to store this important frequency or count of any value which could be beneficial. I'll show you an example. Okay, we'll take an array for input. Let's take I'll show you in both languages Java and C++. Okay, let's take any array for input, suppose 6 elements. Okay, and we need to add all of the elements to the map. So this is how we do it. Now in Java, if you directly want to find a frequency or the value of a key, it gives you exception, null pointer exception. You can only find the value of a key which exists in the map. So before inputting any value or before wanting to find the value of any key, you need to first check whether is it present or not. So if map.contains key a of I. Now if map does not contain the key, I will simply insert the key with a 0 frequency. And now I can increment my frequency. To get your value of a specified key, you use map.get in Java. Okay. Now this code will calculate each frequency of each value of the array. Okay. Now suppose you have some array like this. Then the map becomes like this. 1 is present twice, 2 is present once, 3 is present twice, and 5 is present once. Now if you want to remove an element from this map, this is how you do it. You instead of removing, you won't remove it. You will decrease the frequency of elements -1. Okay, suppose you are removing 1. Okay, then you will remove it like this. And then there is one case which you need to handle. If the frequency of the element you just remove becomes 0, then you completely remove the key from the map. Now I'll show you the difference between these maps. See, you have successfully removed one occurrence of 1 from this map, and this took just over 1 complexity, because map is constant time complexity for all operations. Okay, so this is an example of how you can keep count of all the frequency of, of elements and search within a dataset and delete very efficiently without compromising on the frequency of data. Like in set. In set we cannot keep track of the frequency of all data elements, and hence removing, inserting gives you problems. If the frequency of an element is indeed 0, but you don't remove it from your set, then it can cause issues. But if the frequency is not 0 and you remove it from your set, then that also gives you issues. And hence, for keeping in mind your frequencies and counts, map is a very good tool than set. Now I'll show you how you can do the same thing in C++. Okay, we initialize an vector, same thing, 6 elements. Now in C++, whenever you try to refer a key which does not exist in the map, it automatically initializes it with a default value. Like for int, it gets initialized with 0. If your value is a list, it defaultly gets initialized to an empty list. And so in C++ it is very simple. All you have to do is like this, plus plus, and you can create a frequency map very easily. Okay, to print a map in C++, you can use a pair, because each element in a map is a key value pair, and hence you need to iterate them as a key value pair. Okay, so this is how p dot first and p dot second, and you printed all the elements of the map. Okay, now if you want to iterate a map in Java, then this is how you do it. You have any random hash map here. Now for map.entry, then the data type of the key and value. This entry is the variable name for each entry, is equal colon map.entry set. Now you can print the elements of a map. Entry.getKey will give you the key of the current entry, and entry.getValue gives you the entry of the current, it gives you the value of the current entry. Okay, now moving on to the second concept. The next concept is based on ordered map, where you can perform advanced operations like upper and lower bounds. So in Java, you need to declare a tree map. Okay, you declare a tree map. I'll show you the same in C++ after this. Okay, you declare a tree map. Let's add some values into the map. Now I can calculate. Now there are 4 types of keys. Ceiling key will give us the least key, which is equal to or greater than this key, and you need to check if this key is equal to null, it means the ceiling key is not present. Okay, and you can simply print this key. Now since 2 is present, the ceiling key will be just 2. Then you have something like hierarchy. Hierarchy gives you strictly greater value. For 2 it is 3. Now the other two operations are lower key. Lower key gives you strictly lower key. Now 2 does not have any strictly less key, so it did not mean anything. If I put 5, it would print 4. And then the next operation is floor key. Floor key gives you less than or equal to key. Okay, now there are two more functions which you can use to iterate a sorted map. They are map dot first key and map dot last key. In a in a in a priority queue, you could only access the first element of a queue always, but in a map you can access both the first and last keys. So this provides a very strong advantage of maps over priority queues. Okay, now I'll show you how to use a map in C++, ordered map. Okay, after creating a map, you can define the values like this. You can enter any value inside the map, and this is how you find a strictly greater key. Okay, and now this key is an iterator, which means if you want to find the key value pair for this iterator, you need to use pair, because in map is stored as a pair, is equal to asterisk key. And now you can use p dot first to obtain your key, or you can use p dot second to obtain your value. Now upper bound will give you strictly greater key in C++. Lower bound will give you greater or equal to key. So if you want a strictly lower key, after performing this operation, you need to do key minus minus. And to check whether the value of this iterator is not null, you need to check whether if key is not equal to mp.begin for lower bound, and for upper bound you need to check if key is not equal to mp.end. Okay, now to check if a value exists or not, you use mp.count. Okay, this returns boolean true or false, whether the value exists or not inside a map. Okay, two more functions. Just like in Java, we had first key and last key. You can get the first key in C++ by using mp.begin, whereas you can get the last key by using mp.rbegin. Now, same way in Java as we used first key and last key, in C++ we can use mp.begin and mp.rbegin to find the first and last values of a map respectively. Now, this is a great question to practice insertion, deletion, and upper and lower bounds on a map. Okay, you have to perform four types of queries. One means append a value to the list. Two means delete one occurrence of the value from the list. This is where the frequency is very important. 3 means you need to print the least number that is strictly greater, which means lower key. 4 means you need to print the greatest number that is strictly less. Okay, sorry. This means lower key. This means higher key. Least number that is strictly greater is higher key or upper bounds. And greatest number that is strictly less is lower key or lower bound minus minus. Okay. So here is the solution for it. I have defined my methods fill and remove. The fill method will add exactly one frequency to my value parameter of the key. The remove will decrease one frequency from my value parameter, and if it becomes 0, it will remove the value from the map. If type is 1, I fill. If type is 2 and map contains that value, then I remove it. If type is 3, I find the higher key. If type is 4, I find the lower key. Very simple. Moving on to the next concept. The next concept of maps involves using the value parameter of your element to store a list, queue, set, or even another hash map. This will unlock you to learn more advanced algorithms and solve more advanced questions. Suppose instead of just knowing the frequency of the elements, you need to know the exact indexes of all the elements. So there's where you can use a list inside the map to find any index. If you want for more efficient searching, you can instead of this list, you can use a set, or you can even use another hash map. Okay, if you are storing in indexes, it is guaranteed that there will be no duplicates. So you don't need to worry about the duplicate issue of a set. You can directly use a regular set. Okay, this is how you use it in Java. To add a key, you need to add an empty list or empty queue, whatever you want. And to insert a value in that list, you do map.get add any value, and this is how you make an advanced map. Okay, if you add multiple values, you get it like this. Okay, so you can use this method for many advanced techniques like searching on specific indexes, or you need a specific value from the values which correspond to a current key. I'll show you how to do the same in C++. Okay, so in C++, you define the map as map int vector of int. Okay, and then you can just do map of 2 dot push back any value. Okay, and to iterate the map, it is same as you iterated earlier, just the pair parameters will change. Okay, and need to iterate. Since C++ does not contain inbuilt methods to directly print the vector or map, you need to print it manually like this. So this is how you can use this in this way, where you store your value as a list or maybe even set or queue. Now here's an example of a question where you can use an advanced map, which means, like I explained earlier, you can use a map, list, or even a set in your value parameter of a map. In this question, you are given some segments and you need to insert segments or delete segments, and you need to check whether there are some pair of segments that do not intersect. Now that is not important. Important thing is how do you manage your data. Now in your previous question for list queries, all we needed was the frequency of each element. Now in segments, how we will store this? Okay, I'll show you. We can store a map inside a map. It's kind of like if you have some segments like this 1 comma 3, 1 comma 2, 1 comma 2, 1 comma 4. Then I can store my map as 1 equals to, now I can store ki 2 is twice, 3 is once, and 4 is once. So I am storing a map inside a map, and this helps me to store count of segments, which means this is my L and this is my R map. So basically in this type of map I am storing that how many endpoints of R are present for this particular L. If I have to insert a given segment, I will just add the value of R to this, or I can even increment the frequency. And to remove a segment, I will decrement the frequency or remove the value. Okay, so this is an example where we need to store data in complex ways, like storing a map inside a map or a list inside a map. Okay, important concept for map is interval problem, which means if you are given some sets of segments and you need to calculate that each point is present how many times in all of the segments, you can use map in a way. Okay, I'll explain. Now suppose this first key, let's take this first key 1 comma 4, and here's my map. I will increment my frequency for 1 and decrement my frequency for 5. Since the R is 4 plus 1 gives me 5, and so I will store the value as incrementing 1 for L, decrementing 1 for R plus 1. For 1 comma 5, same thing, increment the frequency for 1, decrement the frequency for R plus 1. Next 2 comma 3, increment the frequency for 2, decrement the frequency for R plus 1. Now 2 comma 5, increment the frequency of 2, decrement the frequency of R plus 1. Now you take a prefix map of all of these values. 1 is present twice, 2 is present 4 times, 4 is present 3 times, 5 is present 2 times, and 6 is present 0 times. If you check this with your data set, then you can confirm that 1 is present twice, 2 is present 4 times, 3 is present thrice, 5 is present twice, and 6 is present 0 times. Now you can also find the frequency of any point in between. Now since 2 is 4 and 4 is 3, which means 3 is also present thrice, which means if I have some value x which is present suppose a times and y is present b times, then all the values between x minus y will be present b times. So in this way you can calculate the frequency which every point is present in all of the segments. Okay, this can be used advanced algorithms and techniques where you are given many segments and you need to calculate how many segments does this point come under. Okay, now let's see some sample questions based on maps. Let's start with consecutive sets. In this question, you are given n elements and you need to keep them in sets. A set can only contain consecutive element and distinct elements. You need to keep these elements in minimum number of sets, and you need to find the number of sets you will need. So in this example, 2, 3, 4 is gone in one set, 2 is gone in the second set, and 4 is gone in the third set. Now, if you sort the elements and iterate it how many sets ever you, will, you will need, then that will cause the worst case to be n square, and that will be very inoptimal. So what you can do is, okay, if you have a certain list like 2 2 2 3 4 4, and you can store your endpoints of current sets. Now, if I want to place 2 on top of some set, which means I need a set ending with 1. Since there are no sets, I will add 2 to my list. Now comes another 2. I need a 1 in the set. There is no 1, so I add another 2. Again 2, another 2 is added. For 3, I need a 2 to be present. So a 2 is replaced by a 3. This count and frequency can be very easily managed by the value component of the key value pair in, in, in a map. Okay, moving on to similarity. Here you have two lists and you need to calculate how many elements are present on both lists. Simple way, you can store the second list inside a map as a key comma frequency pair, and then as and when you come across a value in your first set, you will decrease the frequency of that element in the second set, or remove if 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 it is not present. And here's how you can calculate this value. Farthest greater. You are given n integers. Your job is to print the farthest greater number on the left and the right for each number in the array. Okay, this is a very basic and standard problem for maps which everyone should know. Okay, now let's take a sample array 6 6 2 2. Let's put a big 9 here. 3 5 6. Okay, now this is the technique. You iterate from left to right. If there is 9, you add it. Now 6. Now I will append 6 into my map only if my last key of the map is more than 9. Now suppose you have a dataset like 1 3 1 2 5 6. So now iterate from left to right. Once you get 1 in your map, add it. Once you get 3, add it. Now, before adding each element, you need to check whether this element is greater than the last element in the map. Since it is not, you will not append it. So, this map will turn out like this. Okay. Now, if you want to find the farthest greater for 2, now when I came across 2 iterating, there were no 5 and 6 in my map. They come later. So I will find the hierarchy for this value, which is 3, and hence the farthest greater comes out to be 3. Okay, let's take a more advanced example like 4 6 6 2 2 3. Now over here, if I want to find the value of 2, the farthest left value, my map will contain 4 and 6. Then I just need to find the upper bound of 2, which is 4, and hence the farthest greater is 4. If this value would have been 6 and 4, then I would just enter 6. I would not enter 4 because a greater value is present in my map. Now to find the farthest greater from the right, you need to perform the same thing. Only difference is that you do it from reverse. Like first you will input 3, then while coming behind you will input 6. Okay, so this is how you solve the farthest greater problem. If you want me to create a detailed video editorial about any of the questions from that list, let me know in the in the in the, in the, in, in the comments, and I will make one for you. So thank you guys for watching. Make sure to like and subscribe so you are notified for further videos and lectures.